Today you will be solving linear systems using augmented matrices. So a couple terms. First of all, a matrix, if you remember from Algebra 1, is a rectangular array of numbers arranged in rows and columns. If we look at this example here, notice we have two rows, row 1, row 2, and we have 4 columns, 1, 2, 3, 4. So we say this is a 2 by 4 matrix. The elements are the numbers inside the brackets, so the 1, 2, 3, 4, 5, 6, 7, 8. And an augmented matrix is a vertical bar separating the columns of a matrix into two groups. Okay, so if we look at our system example here, notice your coefficients of x, y, and z are on the far left. And it's almost like you have an x column, a y column, and a z column. The numbers on the far right of the bar represent what the system equals. And our absolute goal when we are solving with an augmented matrix is to have ones diagonally with zeros underneath the ones. That way I can write something like we solved earlier this week with an equation with 3 unknowns, then 2 unknowns, then 1, so we can use back substitution. Okay, and again, our goal in solving a system of equations is to produce a matrix with ones down the main diagonal from the upper left corner to the lower right. And row echelon form is a matrix with ones down the main diagonal and zeros below those ones, as we see in our illustration. So just like with systems, we have matrix row operations. So just like with systems of 3 unknowns, we can interchange 2 rows or 2 equations. We can multiply one row by a non-zero constant. And we can add a multiple of one of the rows to another to replace the latter of the 2 rows. So all we're going to do in this first example is we're going to perform the sequence of row operations. Okay, so first thing it says in A is we're going to interchange row 1 and row 2. So what I like to do is I like to write down the row that is not changing first. Why is that 6 not going? And then we know we're going to flip row 1 and row 2. So the row 1 originally is now row 2. And the original row 2 is now row 1. Okay, and that's it. If we look at B, it says we're going to take 1/3 times row 2. So I like to write myself a little note on the previous step for the next one, just so I have my clarity in my thinking process. And just like with letter A, I'm going to only copy down the rows that are not being changed. So from letter A, I'm going to copy the row 1. And from letter A, I'm going to copy row 3. And notice we're going to take 1/3 of row 2. So it's like we're going to divide each of those coefficients by, or those elements by 3. So 1/3 of 3 is 1, 1/3 of 18 is 6, 1/3 of -12 is -2, and 1/3 of 21 is 7. And that's it. And then notice in C, we're going to take 2 times row 1 plus row 3. Okay, so we're going to take 2 times row 1 plus row 3. So the only row that's a change in here in letter C is row 3. So I'm going to copy rows 1 and 2 from letter B. Okay. Now notice up above in the thinking bubble, it's like when we say 2 times row 1 plus row 3, this is what we're thinking. We're thinking 1 times 2 plus negative 2. And just like it says there, I can do mental math or I can use a calculator. Well, that is just 0. And then we go through the same process. So we're going to say 2 times 2 plus negative 3, which we know to be 1. We'll do the same thing. Negative 3 times negative 2, or negative 3 times 2 is negative 6 plus 4 is negative 2. And 2 times 5 is 10 plus negative 6 is positive 4. And that's it. I would like you to take a minute and try the example you try. Okay, so hopefully for A, that was probably the easiest. You just flip rows 1 and 2 of the original matrix. In letter B, you're going to take row 2 and multiply it by 1/4, which is the numbers in red, everything else stays the same. And then in letter C, you'll take negative 1 times row 1 from letter B and add it to row 2. So essentially what we're doing is we're saying 1 times negative 1 plus 1 is 0. Okay, 6 times negative 1 plus 3 is negative 3. Okay, we're saying negative 3 times negative 1 plus negative 5 is negative 2. And then we are also saying 7 times negative 1 plus 2 is negative 5. So let's look at our steps to solving an augmented matrix. The first thing we're going to do is we're going to write the augmented matrix for the specific system. Afterwards, we'll use matrix row operations to simplify the matrix into row echelon form. And then last but not least, we'll write the system of linear equations and use back substitution. Now technically you can use the matrix to find the solution, but most people will choose to do back substitution. So we will start off by writing our augmented matrix. So you can copy down the X column, the Y column, and the Z column. We'll put a line and then we'll put what the system equals. Now remember, we want the top left to always be a 1. So because the first row does not start with a 1, what we can do is we can interchange 2 rows if we would like to. So if it were me, I would probably choose to switch rows 1 and 2. Now when we write our new matrix, the only row that's not changing is row 3. So I'm going to just write our row 3 first. And you know what? I didn't even follow my own instructions. I got distracted. Okay, so what we're going to do now that the top left is a 1, I'm thinking in my brain, my goal when I am doing the matrix, I want to work down and then across. So I want to work straight down. So the next step would be to turn the 2 in row 2 column 1 into a 1 or 0. And in order to do that, what we'll do is we'll multiply row 1 by a negative 2 and then add it to row 2. So the only row that's not a change in is row 2. So if it were me, I would write everything except row 2 before I get going. And once I've written row 1 and 3, now I can say 1 times negative 2 is negative 2 plus 2 is 0. Okay? I can say negative 1 times negative 2 is 2 plus 1 is 3. 2 times negative 2 is negative 4 plus 2 is negative 2. 9 times negative 2 is negative 18 plus 18 is 0. And now, just like in our thinking bubble, we're going to continue to work down. So I will want to turn this one in row 3, column 1 into a 0. And to do that, we're just going to multiply row 1 by a -1 and then add down. So the only row that's a change in here is row 3. So from our previous step, we are going to just change row 3. So we're going to copy rows 1 and 2 from the previous step. Okay, and now we can go through and say 1 times -1 is -1 plus 1 is 0. -1 times -1 is 1 plus 2 is 3. -1 times 2 is -2 plus -1 is -3. -1 times 9 is -9. -9 plus 6 is -3. And that's it. Okay, now the ultimate goal, now that that first column is completely done, in row 2, column 2, we want that value to be a 1. And in order to do that, I either have to multiply by a fraction, but look at this. Look at this. All 3 of these numbers are divisible by 3, which would mean it is easiest to just switch rows 2 and 3 in our next step. Okay, so I'm going to copy row 1 from the previous step because I know it's not changing, and I'm going to interchange rows 3 and 2. And remember we said we want this value to be a 1, that 3 in row 2, column 2, so we're going to multiply everything by 1/3. And the only row that's changing in this step is row 2. So 0, 1/3 of 3 is 1, 1/3 of -3 is -1. And we want to continue working down and then across. So what that means is I need to turn this 3 to a 0. So in order to do that, we'll multiply row 2 by a -3 and then add it to row 3. So the only row that is a change in is row 3 again. So all we'll do is we'll copy the rows 1 and 2 from the previous step. One times -3 is -3 plus 3 is 0. -1 times -3 is 3 minus 2 is 1. -1 times -3 is 3 plus 0 is 3. Okay, so once we get to this step, now we can write our system. So a first equation is x minus y plus 2z equals 9. Our second equation is y minus z equals -1, and our third equation is z equals 3. All that's left for us to do is to use back substitution to find y and z, or x and y. So we know we'll have y minus z, which we just found to be 3, equals -1, or y is going to equal 2. And then we also know we can find x minus y, which was 2, plus 2 times 3, which is 6, equals 9, or x plus 4 equals 9, or x is equal to 5. Our final step is to write our solution as an ordered triple. So we'll start with x, then we'll do y, and then we'll do z. And that's all you have to do. Oh my goodness. Take a minute and try this example you try. So hopefully with this example, you found your solution to be 1, -1, 2. Yay, and now you can complete the practice. The end.